All right, welcome back. Again, you can check those answers at the end of the lesson. All right, dimensional analysis. Consider a straight pin measuring 2.85 centimeters in length. Calculate its length in inches. This is getting into conversion factors. We spend quite a long time in first year chemistry doing this. All we really care about with dimensional analysis is making sure that units cancel and that they cancel appropriately. Oftentimes on free response questions in AP Chemistry, you get points for your setup. And so having your dimensional analysis work shown is really, really important. So we start with our conversion factor. I know that 2.54 centimeters is equal to 1 inch. So I have two possible conversion factors where inches is on top and centimeters on the bottom, or it's flipped, centimeters on top and inches on the bottom. The way we know which one to use is going to be based off of what unit we start with. We need to multiply our fraction, our conversion factor, so that it cancels the undesirable unit. So here, if I start with centimeters, centimeters needs to be on the bottom for it to cancel. So you see here that centimeters cancels, and we're left with inches. If for some reason I started with 1.12 inches, then I would want inch on the bottom and 2.54 centimeters on top. So that way inches cancels, and I'm left in a final answer with centimeters. And that's really all there is to it. It can get a little tricky with some more complex units, but let's go through and do a couple of exercises. So the pencil is 7 inches long. Calculate that length in centimeters. Okay. So I have 7.0 inches. And keep in mind your sig figs. This is 3 significant digits here. And I know that, centimeters has to be on top because that's my desired unit, and inches has to be on the bottom because that's the unit I want to cancel. So when those cancel, I end up multiplying these numbers together. So let me pull up my calculator real quick. And let's see if we can get these side by side. Aha, there we go. So in my calculator, I've got 7 times the top divided by the bottom. And I get 17.78 centimeters. But remember, I have to check my significant figures. I have 3 significant figures in my starting answer, so I need to have 3 in my final answer. My answer should be 17.8 because the 8 would round up. Okay. Now, when you're using a conversion factor, those are exact conversions, so you do not want to use the conversion factor itself for your significant figures. A common mistake is that you would say, oh, 1 inch is 1 significant figure. But no, with the conversion factor, that is specifically telling you that is exactly equal to 2.54 centimeters. So you don't want to go with the number of significant figures on that because those aren't measurements, they're conversion factors. We want to make sure that significant figures are specific to the measurements that we're looking at. All right, let's do another one. We've got a 25.5 inch frame, and we want to know in centimeters. So again, same setup, 2.54 centimeters on top because that's what we want, inches on the bottom so that inches cancel. 25.5 times 2.54 divided by 1. Now, you technically don't need to put the divided by 1 portion on there because you're going to get the same answer. But sometimes when you do conversions, it's not always going to be the number 1 there. This one also had 3 sig figs. So I see 64.7. The 7 rounds up to 8 if we're looking at this digit here. So 64.8 centimeters is our final measurement. Okay. Now, if for some reason it was the other way around, and let's say it was 64.77 centimeters, and you want to convert back to inches, you multiply by 1 inch on top and divide by 2.54 centimeters on the bottom, and you get back to your 25.5. See, they are equivalent. All right, go through the you try it section. Welcome back. Again, you can check your answers for you try it at the end. Let's talk about some multi-step dimensional analysis. So multi-step, this means you're going to need multiple fractions. You got to come up with a pathway. Here we have a 10-kilometer run. How long is the run in miles? Well, based off of the conversion factors that we have, we know that a mile is equal to 1,760 yards. We have 1.094 yards is equal to a meter. And then we know 1,000 meters is equal to a kilometer. So that's the path we're going to have to work through. If we're starting with my 10 kilometers, and it's 10.0 kilometers, notice the 3 sig figs. I can't go directly to miles, but I know that I can cancel out my kilometers and get myself to meters. And then I can set up my next fraction. If I canceled out kilometers and I'm now in meters, then meters must go on the bottom of my next fraction in order to cancel it out. It says yard here, sorry about that. All right, now meters is canceled. If I'm now in yards, then I can say 1760 yards on the bottom, and that's going to be equal to 1 mile on top. And then in my calculator, 10.0 times the top divided by the bottom times the top again divided by the bottom times the top divided by the bottom. If you keep repeating that process, we get back to our miles, 6.215. And if I check, that's my 3 sig figs, I'd have to round up, 6.22 miles as my final answer here. All right, your turn again for the you try it. Go ahead and work through some of these multi-step problems. Okay, welcome back. As I said, you can check your answers at the end of this lesson. Now we're going to talk about multiple units in dimensional analysis. Sometimes you have complex units and you need to do conversions that allow both units to cancel out. So in this particular one, we're doing miles and kilometers. So we have miles per hour, and we need to change the way we set this up, because if we look at this, 55 miles over hours. And what that really is saying is we have two numbers. This is 55 miles for every 1 hour. So we're going to use that to help us set up our fraction. I have miles on the top, and I want to get to kilometers, so miles is going to have to be on the bottom to cancel it out, and then my kilometers will have to be on top. But remember what we saw earlier, we can't go straight from miles to kilometers. That was the issue we had last time, right? So this actually is the same calculation we just did, but backwards. So what I first need to do, and I'm sure there's an easier way to do this. If you had an exact conversion for miles to kilometers, you could do that, but this is good practice showing you the full step. So I've got miles to, what was my conversion up here? Miles to yards. Yep, 1 mile is 1760 yards. 1760 yards for 1 mile. And then I want to cancel my yards, 1.094 yards for every 1 meter. And then 1,000 meters for every 1 kilometer. Now, what's interesting about this is at the end, when we go through, yards will cancel, meters will cancel, and then you end up with kilometers But remember that hours is untouched on the bottom here. So our final answer is going to have units of kilometers per hour. So 55 times 1760 divided by 1 times 1 divided by 1.094 times 1 divided by 1,000. And I end up with 88, and I only have 2 significant digits here, and that 4 tells me I need to round down, so I end up with 88 kilometers per hour as my final answer. All right, similar idea. Here, a Japanese car is advertised as having a fuel economy of 15 kilometers per liter. We want this in miles per gallon. All right, let's see if I have a better conversion anywhere here. Let's see. I don't. Okay, that's still just going to be a long conversion then. Unless I have another one up here in my table. I don't. Do I have any other conversions up here? Nope, I don't. Okay. So, yep, this is just going to be a little bit of a longer problem, and that's okay. But it's one of the last ones we have to work through, so don't worry. Okay, here we go. So in this one, we are starting in 15 kilometers for every 1 liter. I'm going to first start by trying to get rid of my liters and get that to gallons because I want miles per gallon. Now, because liters is on the bottom, in order to cancel it, liters actually has to be on top. So this is backwards. When you got a complex unit like that, if you're trying to change the denominator, you got to flip everything. So 1 gallon ends up on the bottom. And what this does is this will cancel my liters and leave me in kilometers per gallon. Now that I'm in kilometers per gallon, I can convert my kilometers, which was previously on the numerator, so it's got to be in the denominator, and convert this to meters. And then once I'm in my meters, I can get back to my yards. And once I'm in yards, I can get back to miles. And then if I track my units, kilometers will cancel, meters will cancel, yards will cancel, and my final answer will be in miles over gallons. Those are the only things left. So this is a lot. 15 over 1 times 3.78 divided by 1 times 1,000 divided by 1 times 1.094 yards divided by 1 divided by, times 1 divided by 17.60. All right. And I get 35.2, which would just round down to 35 because of my 2 sig figs. 35 miles per gallon would be the answer to this particular question. All right, you try it, set number 5. All right, welcome back. We have 1 or 2 small topics left, and we will call it a day. Temperature. There are 3 different temperature scales. Temperature, we know, is a measure of the average kinetic energy of particles, not how hot or cold something is. That might be a misconception you previously had. Temperature is specifically related to energy of particles. There's just a correlation with heat and cold as a result. The main ones we're going to use in science are the Celsius and Kelvin scales. We're really not going to use Fahrenheit. And you need to know how to convert between them. Kelvin temperatures are equal to the Celsius temperature plus 273.15 degrees. And that will be on your AP chemistry equation sheet. We also have density. Density you've probably done before. It's the mass divided by the volume. So really you just have to plug and chug there. A chemist trying to identify the main component of a compact disk Cleaning fluid determines that 25 cubic centimeters of the substance has a mass of 19.625 grams at 20 degrees. So use the table to figure out what substance it may be in the cleaning fluid. So first, let's plug in our answer. Oh, where did my annotations go? Uh-oh. I seem to have lost my pen here. Okay, well, I can't write on it for some reason right now, but we will do the mass 19.625 divided by 25.0, and we get 0.785. And that density of grams per cubic centimeters match up with isopropyl alcohol. All right, I think that's it for the calculator for now, so I'm going to go back to full screen. Hopefully this works out for me. All right, so states of matter. There are 3 states of matter that we've learned about in first year chemistry: solids, liquids, and gases. Yes, plasma is one too, but we're not really going to focus on plasma in this course. Solids are rigid, have definite shape and volume, and they are very close together, and they vibrate at fixed points. So there's still motion within solids. With liquids, there's a definite volume, but it takes on the shape of the container. Molecules still vibrate, but also have rotational and translational motion, which we'll talk about a bit more at another point in time. As a result, they can slide past each other, but are still close together, and therefore they're slightly compressible. Whereas gases, on the other hand, have no definite volume. They take the shape of their container. They have every kind of movement possible: vibration, rotation, and translation, and they're relatively independent of each other. As a result, they're very far apart and they're highly compressible. The term vapor refers to the gas phase of a substance that is normally a solid or a liquid at room temperature. A fluid is gas or liquid, anything that can flow. And I've got some good diagrams here. You can see the particle representations, the very ordered arrangement of a solid, very loose arrangement in a liquid, and then essentially no interactions when they are in a gas form. When they transition between ice, water, and steam, or solid, liquid, and gas, energy needs to go in to separate the intermolecular attractions occurring between the molecules. So that is something you will have to review as your intermolecular forces. When we're talking about classification of matter, we have mixtures, which can be homogeneous or heterogeneous. Homogeneous visibly is indistinguishable. It looks the same throughout. Things like solutions, Gatorade, lemonade, things like that, as long as it doesn't have any pulp. Once it has pulp, it's heterogeneous, and it could be subject to filtering or some sort of separation technique, like chromatography or distillation. They have very visible parts. Here's just a picture of a distillation apparatus. You probably won't get to use one of these in AP Chemistry, but they're cool to look at nonetheless. Pure substances. These are compounds and elements. So compounds can be separated into elements by chemical means. Elements can even be further broken down into protons, neutrons, and electrons, but they have to undergo quite a lot of energy to do that. Huge energy transfer. Okay. So then here's just our flow chart, and this is really the last of it, and what we need to know for some chemistry fundamentals before we get into atoms, molecules, and ions. In our next lesson, we'll have a larger discussion on atoms, molecules, and ions. That is all for this lesson. Have a great day.